Going to talk to us about getting the most out of Python imports. This is going to be a 30-minute talk, including a 5-minute question and answer interval at the end. Eric Snow.
All right. Thanks for coming, everybody. Really appreciate it. Today we're going to talk about imports, which is something that I've gotten to know pretty well over the course of last year. And I'm really excited about it. This is, Brett Cannon here has really done a great job with all the work he's done with the imports. And part of the reason I've learned so much is just because of my involvement with some of the projects he's working on. So let's get to it. First, and most importantly, if you're looking for squirrels, they're in D5. I don't hold any animosity, though, so it's okay. So the Python import system is really powerful. There's a lot you can do with it. I've listed up just some of the things that aren't really that hard to do, well, to a degree, but for the most part, you can accomplish all of these in a really straightforward way using the import system. And we'll talk a little bit about kind of the fundamentals that it'll take to get this working. So first of all, let's say you had some source that you wanted to take some code, just some source, and you want to transform it somehow. You're going to tokenize it and do some stuff to it. And what would this be useful for? Let's say you wanted to strip the U prefix off of strings. That's a meaningful use case. You can do it. So you'd take that transform code, you'd pass it through here, just a generator to give you back your string of tokens. And then you could use this import hook right here to go ahead and actually, during import, apply that transformation. So it may look like complicated, but it's really not. And so we'll talk about how all this works. So I actually wanted to read this so that it was more funny. So this is something that I asked Guido about imports, and he said, about a recent conversation he had with a friend. A friend said, after a lot of work, I think I finally understand Python's import mechanism. And then Guido responded, don't worry, that feeling will pass. And I can see where he's coming from. There's a lot to it. But you look at it, imports are really the heart of the language. Other than your main module, everything you run goes through the import system. It's executed through the import system. And so the power of imports lies in the ability to make the language do anything through imports. So to get there, though, you got to really understand the basics, which is the information's scattered all over the place. So one thing I've been trying to do, and I was hoping I'd have it ready, but it's not quite ready yet, just have a nice one-stop reference for the whole import mechanism. So it'd make it a lot easier in this regard. But hopefully today this talk will help somewhat. So let's first talk about how imports work. So we can kind of look at it at different layers. First we start at the import syntax. What's it doing behind the scenes? It's calling the built-in import. In fact, there you go, calling the built-in import. And then the names get bound, and there's a few more things going on. What does the built-in import look like? Basically, first it's going to check to see if you got the module already loaded, kind of short circuit there. And then it's going to go through this sys.metapath and try and find an object that matches, essentially, using the information that it has available. Once you get back this loader, it's going to go ahead and if the loader actually is valid, it's going to use it. It's going to return the load module on the loader, and you'll end up with the module. So really pretty straightforward. There's more to it, but it's pretty straightforward. So as we step through this, great. The loader, you can think of that as kind of like a pre-module. It hasn't been loaded yet, but it holds all the information that you need to load it. And then the end result is that we just have a module that's all working and that is already stuck into the system modules. Wonderful, nice and easy. Okay, then at the next layer down, we have import hooks. So import hooks are, again, really straightforward. If you look at PEP 302, there's a lot of information there, but really what it boils down to is we have these finder objects that have a find module, and they give us a loader, and they get used during imports. One layer down, we've got path hooks. We'll talk about those in a sec. Because I want to talk a little bit about metapath hooks. They form the meat of this, the basis of this import process. And then on the metapath, by default it's empty, but there are 3 implicit ones here. And the default pathfinder is where the path hooks come in. So if that default pathfinder, the way it works is it's going to check different information. We'll look at we have this in just a little bit, but these finders are on the metapath. Anyway, as far as the history of imports go, we've always had the import statement, packages, and they came a little later. The dunder import exposed and able to overwrite it is something that was added in 95 and so forth. I mean, the main things, there are more events that happen, but these are the main things. And most recently, there's work going on to make Importlib's import the import mechanism that's going on instead of the one that's in C, which is kind of a big deal. And then at the bottom layer, we have the import state, which is basically just those parts of Python that describe the information that the import system will be using. So it's good to keep those in mind, but there isn't a whole lot to remember there, which is nice. Okay, so let's look at how the default pathfinder works. First of all, we're going to go through and check this sys.path importer cache, which is just a dictionary, and it matches individual paths to finders, these finder objects. So then it doesn't have to look them up later, because if it doesn't find it there, the next thing it's going to do is check the sys.path hooks for these objects that it can call to see if they know what to do. If they return something meaningful, then it's going to use that, it's going to cache it, and it's going to move forward. It's going to use the finder that gets returned to move on with the import process. The finder's returning a loader, and the loader is used to actually load the module. And then finally, if nothing sys.path hooks works, it's going to check, it's going to actually use the default path hook, which is itself just a finder. And so, again, there's really not a lot to it. There's just kind of a lot of little details that add up. So it's more just having in one place a good view of what's going on here and keeping all the details with decent explanations. So hopefully this makes sense. There's actually not a lot of more detail per se, but we'll talk about how they work and look at some examples in just a moment. Importlib is something that was added in 3.1, and it provides a lot of functionality that you can use to customize imports, including some abstract base classes and a few other helpers, as well as providing an import module and the dunder import, which is essentially going to be used for the import mechanism of Python in 3.3. So if we look at this again, that's actually a slide that wasn't supposed to be there. Okay, now let's talk about how how we use all this information. Saw how it all works. Let's dig a little more into it. First of all, like I said, the import system is really powerful. If you can customize it and you're aware of how it works, not only will that help you understand what's happening in your code and what happens during imports, and you can take advantage of that, but you can actually plug into it through the import hooks and tap into this power, the ability to make Python do whatever you want it to do. So first of all, a couple things that you can't do, though, because the import system doesn't get triggered until you import something. And so the main module, the script you run, that's not going through the import system. So you can't customize that using the stuff we're talking about today. So it's good to recognize that scripts are not modules. And there are a few other things that you can't affect just because you can't modify them through Python. And that's the underlying implementation of the language to some regard. I mean, it already exposes some of that stuff, but some of the stuff it doesn't expose, and there's not much you can do about it. Okay, so what do? You can write your own little wrapper functions around stuff. You can overload the import statement by just writing your own import and replacing built-ins under import. You can install metapath importers or path importers. And finally, you can hack the import state, but I wouldn't recommend it. So first of all, we'll talk about, well, mostly we're just going to focus from here on out about metapath hooks and path hooks. First of all, these are 3 examples that I'm going to show you, and then that'll pretty much be the end of the talk. First of all, a simple one. We're just looking at an import hook that'll log stuff when we try to import it, but it's not going to do anything else. And what happens here, you'll notice, that it returns, well, it returns none. I have it commented out, but that's essentially what's happening implicitly. And when, on the metapath, we're going to stick this on the metapath, you see there. On the metapath, when one of these finders like this, the find module returns none, that means it didn't match. Move on to the next one when it's in that loop. But when it doesn't return none, then it's going to use the loader that got returned. In this case, we're returning none. So all we're doing is saying, hey, we got an import going on. We just want to log it. Great, pretty straightforward. So once we have our class, we just append it right onto the sys.metapath, which is just a normal list. In this case, we're appending on an instance of our class. But really, there's not a lot of information that we need to worry about here. I mean, we're just going to keep track of the name and the path that we use for this import. Great. And like I said, that loader, in that case, is going to return none, so it'll just skip that little part. One thing to remember is that if, with the current import system, and I mean, that's just the way it's going to stay, but when you go to import a module and it's already been imported, this will short circuit. So even if you have a hook in there, in this case, it's not going to log anything if the module's already been imported and you have an import statement. So just keep that in mind. That short circuit happens before we go through the metapath loop. Next, the example where we approach finders and loaders with 2 different classes. So we have a finder here that doesn't really do much. It's a subclass of a list, and so when we're going through, maybe we want to pop on there a few names that we care about, modules that should be blocked from importing, and then it'll go through and it says, oh, if that name, one of those names, or the one that's currently being imported is in that list, then we're going to take care of it. And so then what will happen is it'll return the loader. I think I got a typo on there. Instead of self.loader, it would be an instance of blocking loader. So with the blocking loader then, so you'll remember that find module will return a loader, and that loader gets used. So then when this blocking loader instance gets used by calling its load module, all we're going to do is check to see if it's not already imported, and if it isn't, then we're going to throw a fit about it. So pretty straightforward. I mean, there's not a lot to it. The key is the find module and the load module. All right. So now, what if we want to combine those into one class? This is really the same thing here. So we're going to add this import blocker, which is now a finder and a loader, onto the sys.metapath, or an instance of it. And we can do this so that, somewhere else maybe we want to add extra modules on there, or the names of modules, and so we have access to that blocker. And it's going to do the exact same thing, but now we've thrown it into one class, and I don't know, again, pretty straightforward. We're just returning a copy of self in the case where we've returned a copy of that blocking loader. And then we can handle load module just like normal. Okay, so now those were metapath hooks, metapath importers. If we want to go down the next level to the path importers, remember that it was a callable that if it can handle that path that it's passed, just a path, it's going to return the finder that should be used for that path, which will get cached, and it'll get used over and over whenever you use that path. So let's look at an example. Oh, real quick, keep in mind that you can import from a zip file, right? And that's facilitated through the zip import, which is one of the implicit import hooks. So it knows how to import zip files, or from inside of zip files, which is kind of neat. It was one of the first applications of the import hooks from PEP 302. Okay, so let's look at, this is the stuff I was just saying. This is kind of the steps that we go through. Check the importer cache, try the importers on the path hooks, and then we'll default to the default path hook. Great. And the path importers, these callables, so that with the metapath hooks, if it returns none, it means I don't know what to do with it, move on. With path importers, it's a little different. If it returns none, it means use the default behavior. But if it raises an import error, that means I don't know what to do with it, move on to the next one. So it's a little different, but not a terribly big deal. You just got to keep the two separate. Metapath hooks and path hooks behave a little differently. And then, of course, if it knows what to do with it, it can return a custom finder. Okay. So, all right, here's a simple example. We throw this path importer onto the path hooks, and whenever we get an import, and it's not a path that we know about already, we're going to print out, it's our first time looking at it, and then raise an import error. We know it's the first time because the import error will say we don't know what to do with it, move on to the next one, and eventually it'll either blow up or it'll get some other hook that it's going to use, the default one really. So we know that, and then that'll get cached, so we know that this will get used only the first time. It couldn't find it already, which is kind of nice. So we can keep track of when a path is getting imported on for the first time. But it's really straightforward. You throw that into sys.pathhooks, and it's going to work. Let's see. So, Brett, he really has done a lot of work. He started working on the Importlib years ago. And with all those going on with Python 3 and all the work that was being done, he's put up some good examples, and he was able to still stick with Importlib and give us some good tools for working with imports. So if we look at Importlib, again, like I said, this is what we got in there, import in the import module, and then 6 classes, abstract-based classes that we can use. We've got the machinery, which is 3 additional classes. It's essentially versions of those 3 implicit meta path hooks. And then in the util, we have 3 decorators that are handy for writing your own import hooks. And then if you go and look on the Chi shop, you'll find that he also has another package out there that provides extra stuff that's really useful for writing import hooks. Which is kind of neat. I mean, importing stuff out of SQLite. Kind of clever. Okay, so when would you use all this? Really, it's true anytime you want to change Python's behavior. This is really applicable. I mean, one of the reasons I got thinking about this a lot is because when people come out and they come up with new syntax ideas, you want to try them out, one nice thing to be able to do would be to use an import hook to just write your code in this new syntax and have the import hook transform it into valid Python code. That way you can try it out, tweak it, test it out, and not have to really dig into Python's underneath and add the syntax to it, which is not trivial. So, I mean, that's just an example of the sort of thing. I put up that list at the beginning. All sorts of really cool things that you can get out of imports that are hard to do elsewhere. And it's just a matter of understanding, having that big picture of how imports work, also understanding what an import hook is, the meta path, and the path hooks, and that's essentially it. Just what goes in the meta path and what goes in the path hooks. That's all I got. All right, we have questions?
I have a question. I don't know if this was in your presentation, I just missed it, but can you tell me about the imp module, which I've seen frequently used for importing? What does that do?
Okay, so if you've looked at the CPython source code, which I don't know how many of you have, but it's organized pretty straightforwardly, and all the import functionality for the underlying implementation of Python is in this import module, import.c, and quite a bit of that implementation is exposed in the imp module. Now, one of the things that's going to happen with Importlib getting a more prominent place is that a lot of the functionality which is duplicated in the 2 places will probably be pulled out, but still it will be, the APIs that are there will still be exposed for backward compatibility. But yeah, it's basically, there's a lot of duplication. I would check Importlib first, and then there's some functionality in the imp module, but really it's, you can get pretty much everything out of Importlib.
So imp is deprecated and importlib is the new way to go?
No, it's not deprecated. Maybe it'll come to that, but right now it's not.
Okay.
It's old and busted versus new hotness.
Yeah.
Okay.
Old and busted, new hotness. Yeah.
Are we able to reload a module after they be loaded?
Well, reloading modules is a tricky thing because it's like the difference between copy and deep copy. And so you got to keep track of, you can trivially reload a module, but everything that pulls stuff out of that module isn't going away just because you reloaded the module, right? And there aren't those sorts of links that'll automatically update just because Python's a dynamic language where we're binding names like that. Those objects are still going to be bound to those names in other namespaces, so you reload a module and all bets are off with anything that was using stuff out of that module. So the reload, I mean, that's one of the reasons why it's not as useful as you may think.
I have a question that's related to the IMP module. What's up with the iHooks module?
iHooks?
Yeah.
iHooks, if I remember, I got removed in quite a while ago. No, iHooks. Is that in?
I have 2.7 code I'm working on right now that's breaking with iHooks. So.
Well, iHooks isn't part of the standard library.
Yeah.
It is? Well, there you go. Undocumented. But
Okay, don't use it. Cool.
Well,
The-
its points, its usefulness is going away with Importlib. So.
Okay. A second, maybe not related question is what's
Okay.
up with the nspackage.pth files?
the PTH, well, I'll tell you, and this is one of the problems. When I was working on this talk, at one point I was up to like 150 slides.
Yeah.
You know, and I figured that was a good way to approach it, and then narrow it down. And so there's a lot of information about imports that we could talk about, and the .pth files is one of them. It's basically being able to add stuff to your sysdot path permanently. So what'll happen is when things get looked up on your sysdot path, it'll actually look in each of those directories for .pth files. And then what's happening is the paths that are listed in the .pth files are added to sysdot path.
Okay. Just for clarity, there's a difference between the PTH files and nspackage.pth files, which have the word import in them, and then there's a check that doesn't
NS
do the,
package?
Yeah. Look at paste. Yeah. It's
So .pth files basically just list paths that get tacked onto the sysdot path from the site module. It's actually not import doing it. So
Right.
if you look at the site module in Python, that's what during startup is actually adding these paths.
Right.
This ns.pth has nothing to do with Python specifically. It's not like it's a paste thing.
Yeah.
But the import statement just means anything import whatever automatically just gets executed by the site module. Anything that doesn't have that is just considered a path. That's all there is to it.
okay.
Yeah, it's pretty straightforward.
Yeah, thanks guys.
Yeah.
So I have a question. Reloading modules just came up, and there might be problems, but it works. But it doesn't work for C extensions.
Okay.
Does it work for C extensions in Python 3? Oh, it does.
Martin Pommelos fixed that.
Yep.
3.3 or?
I think it was fixed in 3.2.
Uh-huh.
So another reason to upgrade all your code, right?
So I've actually seen quite a few people write PEP302 import loaders, and there are a lot of very subtle things in it that it's very easy to get wrong. Do you know of any good ways of actually testing this thing? So it's quite a deep thing in Python. If you raise an error in the wrong spot as part of the machinery, it can break your code in subtle ways later.
Well, I suppose you want to test them the same way you test everything. You got to look at what you're trying to do. As far as problems that are general to the finders and loaders that you would test against, that's a good question. We could talk about it a little more after if you'd like.
Okay, thank you.
Anyone else has any questions? Okay. Thank you very much, Eric.